Field Testing Concrete, Part 2. This program covers the slump test and casting cylinders for compression testing. We'll start with the slump test. Basically, the slump test consists of filling a standard slump cone with concrete, rodding it to consolidate the concrete, then lifting the cone off and measuring how far the concrete slumps down when it's not supported by the cone. The slump test is a measure of two things, uniformity and consistency, and it indicates how workable the concrete is, whether it's relatively stiff or more fluid. Here are two examples with different slumps. It's a bit confusing to beginners, but you'd refer to the one on the left as having a high slump. The one on the right has a low slump. When you think about it, it makes sense. The concrete on the left slumped farther, so it has a high slump measurement. The procedure that you'll see here is based on test method number 804. The construction manual covers the procedures and the equipment used. You need to run one slump test for every 100 cubic yards of concrete placed. To run a slump test, you need first a rigid, stable base that won't absorb water from the concrete sample. A wet piece of plywood is fine. Just make sure there's no freestanding water on it, because that would affect the concrete. Second, a standard slump cone. It should be reasonably clean with no major dents. Make sure the inside is smooth, no dried concrete. Third, the tamping rod. Make sure it's the standard rod, made for concrete testing. It's not acceptable to use a cut-off reinforcing bar instead. The bar has to have a rounded tip, so that the large aggregates aren't pushed to the bottom when the concrete is being rodded. Next, a scoop. The kind with a rounded bottom is best because it makes it easier to get the concrete into the cone. And finally, something to measure the slump with, a ruler or measuring tape. And that's all the equipment you need. The base, the cone, the rod, a scoop, and a ruler. Now for the test procedure. To begin with, of course, you need a sample remixed until it looks uniform. Dampen the inside of the slump cone so the concrete won't stick to it. And dampen the base as well. But remember, no freestanding water. Place the cone down on the base, as close as possible to the concrete sample. Make sure the base is level and firmly supported. It has to be flat and stable. That's a must. The person doing the test should step onto the footholds at the bottom to hold the cone steady and stay there. That's why the cone should be close to the concrete sample. Now we can start filling the cone. It's best to move the scoop around the top to get the concrete distributed as evenly as possible. The cone is filled and rodded in 3 layers by volume, not according to the height of the cone. The first layer should come up about 2.5 inches. The second layer should come up about 6 inches, about halfway up the cone, and the third layer should overflow. To make it easier to get the right depths, some people mark the outside of the cone at the 2.5 inch and 6 inch levels. They don't have to, but it does make the testing more accurate. Okay, he has the first level in the cone. Now rodding. With the rounded end of the rod downward, he rods the concrete 25 times, starting at the outside, spiraling toward the center. And he's rodding deep enough to just tap the base. Now notice one thing. When he's tamping at the outside edge, he holds the rod at an angle so it's just about parallel with the side of the cone. That's the way to do it. If he held it vertically, he'd miss the edge. It wouldn't get rotted properly. Now he's ready for the second layer. Again, it should reach about half of the cone's height. The second layer is rotted just the same as the first, 25 times, starting at the outside and spiraling toward the center. But one difference, he doesn't rod to the full depth of the cone. The rod should go just deep enough to penetrate the first layer by about a ½ inch. And there's an easy way to make sure the rod goes to the right depth. Just grip the rod at the right distance from the bottom tip. 12 inches for the first layer, 10 for the second, and 6½ for the third layer. And rod downward until the hand just reaches the top of the cone. Marking the rod at the 12, 10, and 6½ inch points can help you to position your hand quickly and correctly. Okay, ready for the third layer. As I said earlier, the third layer should overflow the cone. The concrete should stay above the cone throughout the rodding. If it drops down, stop rodding. Add concrete, then finish with the 25 spiraling strokes. No more than a total of 25 though. The rod should penetrate the top of the second layer by about a ½ inch. The cone's full and the rodding is done. The next step is to use the tamping rod to strike off the concrete at the top. The top should be fairly smooth, so it's best to use a sawing motion and roll the rod at the same time. There, level and fairly smooth. The next step is to remove any concrete that is spilled around the bottom of the cone. That's important because any concrete down there will keep the sample from spreading out when the cone is lifted off. Now the cone can be removed. Notice that he places both hands on the handholds and presses downward to keep the cone stable while he takes his feet off. If it's done improperly, removing the cone can ruin the test. Here are the rules. Pull straight up with no twisting or tilting allowed. It should take about 5 seconds. It takes a steady upward lift, slow enough so the concrete doesn't pull on the cone. Now set the cone down next to the concrete, being careful not to jar the plywood base. Lay the tamping rod flat across the cone and measure the distance between the bottom of the rod and the top of the concrete. Measure to the nearest 1/4 inch. You'd record this as 1 3/4. Now here's an important point about measuring. Measure from the bottom of the rod to a point on the concrete that is directly above the center of the bottom of the concrete, not at the center of the top. If a fair amount of concrete falls off or shears away, the test is invalid. Make a new test using another portion of the sample. And that's the slump test. On a stable, flat, non-absorbent base, fill the cone in 3 layers by volume, not by height. Rod each layer 25 times, spiraling toward the center. Strike off the top layer, clean around the base of the cone. Lift the cone straight up without twisting or tilting it, and measure from the bottom of the rod to the top of the concrete, directly above the center of the base of the concrete. There's a time limit too. 2½ minutes between the point where he starts filling the cone to when he measures the slump. Always document the slump measurement on the delivery slip. If the slump is not within the range that's called for, discuss the deviation with your supervisor right away. And of course, after the test, the equipment should be rinsed off, especially the rod and the inside of the cone. Then it'll be ready for the next time. Now, on to casting cylinders in the field. Again, casting, testing equipment, and methods are covered in the construction manual, test method 809. First, the equipment needed. Standard cylinder molds, a tamping rod like the rod used in slump testing, and a scoop or a blunt-ended trowel. As part of the preparations, Make sure there are enough cylinder molds on hand. You will need to make at least 2, and more if the pour will be over 50 cubic yards. The procedure for casting cylinders is very much the same as the slump test. 3 equal layers of concrete, rodded 25 times in the same spiral pattern. You'll need a random sample of concrete, as you saw in part 1 of the course. Be sure to get enough concrete to run all your tests without reusing any of it. Place the first layer into the mold, moving the scoop or trowel around the lip of the mold. If the concrete isn't distributed evenly inside the mold, use the tamping rod to move it around. Rod it 25 times, spiraling toward the center. Full depth for the first layer. Place the second layer and rod the same way, but deep enough to penetrate the top of the first layer by about 1 inch. You'll recall that slump tests call for a penetration of just a ½ inch. If the rodding leaves holes in the concrete, you should pat the sides of the mold with your hand, very lightly, to close up the voids. Then for the third layer, overfill the mold. Then rod the same way, 1 inch or so into the second layer. Strike off the excess concrete with a trowel or a straight edge, using a sawing motion. Mark the contract number and the cylinder number on the side of the mold with a black felt tip pen. Number the cylinders sequentially, from the beginning of a job to the end, for each class of concrete. Be sure to record the numbers in the cylinder book. You have to know where to find the concrete that the cylinders represent. Cylinder curing is a critical part of the testing. Try to keep all cylinders undisturbed for the first 24 hours, buried with dirt within 2 inches of the tops, covered with the caps supplied with the cylinders. But that's not all, because there are variations, which your instructor will discuss after the